Good evening. Welcome to Space Oddities on this Tuesday evening. Sorry we're a little bit late. We had a bit of a technical hiccup, but we hope you all well out in YouTube land. And we've got a packed program this evening. Thank you for joining us. We hope you're all well. And I'm joined this evening by Daz again. Let's do it all again, Daz.
Oh, okay then. If we must. As I said, how long have you got? Because it will take a long time for me to go through all my maladies I've had this week. So
you're not well, are you?
No. It's just I'm a miserable old git.
Oh, okay.
It's just one of those days. No, I'm really fine. I really am fine. We've actually got some clear skies tonight, so hopefully I've also got an aurora alert coming through. So maybe that might pick up. It's all looking good here at the moment.
Great, fantastic. All right then. Good evening, Michael. Again.
Good evening, Andy. All well here, including a clear sky as well.
Yeah, and what is that behind you, Michael?
It was the failed lunar lander.
Ah, well, no wonder it failed. It's landing on the Earth. Look.
Yes.
Yeah.
It was IM1, wasn't it?
Yeah, absolutely.
Yeah.
So there we are. From Deepest Spark, from where I gather it's clear again, we have Roger.
Yes, another clear evening for some moon imagery.
Oh, fantastic. A lovely one behind you there, Roger.
Of course, that was from 2 nights ago.
Wow.
Oh, wow.
But more about that later in the gallery.
Oh, okay. Yeah, I gather we have quite a sizable gallery this evening.
We do have a few images, yes. There is a theme running through them on quite a few.
Oh, good. I wonder what that would be. Okay. And we're joined by Mr. Keith Mosley and his library. So how are you, Keith? How's the library?
Yeah, fine, thanks. Yes, you're looking at about 50% of the books my wife wishes I didn't own.
I know the feeling. I know. Oh, and I was about to say we're joined by a planetary scientist extraordinaire, Mr. Lumeo, live from Boulder, Colorado, where he's attending a conference. Tell us a little bit about the conference, Lou.
Yes, well, it's a space weather conference. So it's about the impact of the sun and its solar wind and solar storms on the Earth, and a little bit on, there are some presentations on space weather on Mars and on the impact of space weather on astronauts who will go to the moon and Mars. So it's a fascinating conference, a lot of emphasis on artificial intelligence and its ability to model space weather events. And apparently, even though it's not tied to any physical reality, it just uses tons and tons of observations, the AI models work very well. So here I am in my hotel trying to get a little bandwidth going. Otherwise, life is good.
Glad to hear it.
So Lou's still on the lam, is he? He's still hiding.
Still on. Oh, am I hiding? Oh,
on the lam. He's on the lam.
Yes, if you're wondering why Lou appears to be merging in from a bank of clouds, because he seems to have clouds in front of him intermittently. It's a neat trick if you can manage it, that's for sure. As from Liz, we'd like to inform you that Space Oddities is being sponsored by God, so it can only go well. So there we are. Right. Okay. Well, Lou's having a bit of a problem uploading his presentation for later in the program. Let me tell you what we've got up on the program this evening. We've got the usual gallery, which this week, as Roger said, is quite extensive. We've got the news section, which I'll be telling you all about the latest news. There's some really, really interesting news tonight, as ever. We've also got Daz is going to talk a bit about the sun. Keith has got a quiz for us, and Michael's not going to do anything. So Michael will be telling us about a science fair coming up.
Yeah, just a quick one. If anyone's got any ironing, just drop it round to Sandra. She's busy doing them now. So. But also, as I said, we've got an aurora alert going on. And Astro Nebulae said the aurora readings are going bonkers at the moment here. Let's hope they hold weather and stays clear till later. So, yeah, hopefully we might be able to get some. We weren't expecting anything. That's a strange thing. But we'll talk about that later.
Okay, all right. And if all goes well, Lou will be telling us about, guess what, the Great American Eclipse, which he attended and had a good time. So we'll be doing all that. So just a couple of things before we start. We'd like to thank you very, very much, as always, for the coffees that you're buying us and the super chats as well, because all the money, as I say every week, goes into the coffers and helps us keep the show running, keeps the ship on course, and allows us to develop the channel and do the things that we really want to do. So your generosity is amazing, and it is truly much appreciated. Now, last week, as you may remember, we asked you to choose the design for the new Space Oddities T-shirt and hoodie for the summer. And we're pleased to announce that both are now available. Here is the Space Oddities T-shirt for 2024 with your design on that you chose last week. It's now available in one of 10 colours, £20, including UK postage and packing. Jolly good price. You can buy it by either scanning the code there on the screen. If you look in the chat, there'll be a link in the chat, and there's also a link in the description of this video.
Can I correct you on
ways
that?
of buying this amazing garment.
Andy, can I correct you on that? I think it's only available in black.
Is it?
Yes, the description was wrong on the website. It's because it looks better in black than the other colours.
All right, then. So let's just rephrase that. You can have any colour you like as long as it's black. So we will edit that banner there accordingly. And we have also got a hoodie available. I haven't had a chance to create the QR code for that one. But if you just go to Skullprint, the company who are supplying our T-shirts and hoodies, just search for Space Oddities. When you get there, you will find it. But next week, I'll put a QR code up that you can scan. And all contributions are gratefully appreciated. We all love the new design. We're really pleased that you chose it, because actually it was our favourite as well. But we wanted to give you, the viewers, a chance to choose the one that should be worn in every place of any importance this summer. And we're very happy to bring you that new T-shirt. This does not mean to say that the old designs are still are not available anymore. They are. This is last year's thing now, very passé. But if you would like to buy the old design, then you can buy the T-shirt by, again, scanning the code, clicking the link in the chat, or clicking the link in the description of this video. We've got the inevitable Space Oddities hoodie available in pullover or zipper type. The pullover type has the design on the front. The zipper has the design on the back. These are £40, including UK postage and packing. Whatever you buy, if you are buying from outside the UK, you need to add £10 to the total value of your order to include postage and packing to outside the UK. And we have also, of course, the Lapel design T-shirt with the last year's design on the lapel. These are really good. You can have them in a short sleeve or long sleeve version. The long sleeve version will cost you an extra £3. The T-shirt, as ever, £20, including UK postage and packing. So that's the merchandise advertising out of the way. And we've got a packed program. So what we're going to do, as time dictates, we will go over to Roger for a look at what's up in the sky and this week's gallery. So take it away, Roger.
Okay. Oh, look, we've got the design on the front slide. How
It's
handy
spreading
is that?
like a virus.
Oh, dear. It's getting out of hand. Anyway, so the 16th to the 22nd of April. This is what the moon looked like last night, first quarter, but it's moved on a bit since then, obviously. And the sun is now getting a bit more spotty, as you can see from today's view of the sun. So activity is progressing nicely. And obviously we're moving on towards a full moon through the early part of next week, unfortunately. But through the sky at through this week at 10 o'clock on here, we can see finally the great warrior of Orion, the hunter, is now gradually sinking into the western horizon with Leo still dominating the skies, and we've got Booties and Hercules coming up through. And a bit later on, we'll be getting the Summer Triangle coming up through as well. So that should be...
And that's how we know it's summer.
That's how we know it's summer, yes, as you can see. But obviously, as the week progresses, we get the brightness of the moon interfering. But Sunday the 21st, we've got Ponsbrook the Comet, although it will be getting more of a challenge now as it gets down low to the horizon, as it's getting just about dark enough to be able to see it. It gets to its peak brightness. And the 22nd, we've got the Lyrid meteor shower. But that will probably be best seen in the early hours of the morning because of its position of Lyra in the sky during that period. But in the morning, we've still got some planets rising up before sun, but obviously with the bright dawn sky, we won't really be able to see any of them at the moment. Saturn, Mars now splitting away from each other from their conjunction last week. Venus is still visible, but Mercury definitely not, unfortunately. But obviously Venus being that much brighter is a better chance. So I've got a few cometary details here. I've got 3. This is Comet Obers, which is transgressing through Taurus between the Hyades and the Pleiades. That's not quite as bright as we're currently expecting with the other one, but it is brightening up.
Yeah, it's not bad.
So it's going currently at magnitude 8, and it will be just under magnitude 6 by the end of May. But then obviously, as it's going through Taurus and then onto Auriga, it will become very difficult because of the setting times of those constellations at the time of when it gets dark enough to be able to see it. But an opportunity. But this one's a better one because this is in Virgo, and this is Comet 23A3 Sunshine Atlas, and that's heading up into the Virgo bowl of galaxies, which will be of interest. It is a lot fainter, but it will promise to be a lot brighter before the end of the year, and some forecast it to be about minus 1.4.
Wow.
We shall see. We shall see.
Yeah.
We know how these things can happen rather rapidly. But currently, Ponsbrook is still transferring through Taurus at the moment and heading on towards Orion. But obviously, its current position makes it a bit of a difficult target unless you've got good, low, clear skies to be able to see it when it gets dark enough. But yeah, in the next week or so, it's just going to be down to about minus 4.9. So not too bad, still quite good. I think the tail might be worth catching as well to see what we can see how it's transferred. But here's the gallery with the new logo on it.
Lovely.
Lovely.
Right, okay, first image is from Jerry DeLay of the Pinwheel with his 6-inch Ritchie-Chrétien telescope.
Ooh.
Oh, wow.
Hey, that's
Very good.
neat.
Very good.
That is amazing.
Very good. Of course, that was where the supernova was, wasn't it, last year?
Yeah.
Yep.
Yeah, that's right.
And first image, one of many images of the moon that we've got today will be first one's from Graham Turvey with his sea star. And this is a 30-second raw video which he's stacked. And that's what he's got.
That's nice.
Wow. That sea star's amazing.
It's very good.
Yeah.
Very impressive.
Feels
Very
like I'm there, doesn't it? Standing
Absolutely.
on
Very good. Very good. Sonia, who's done another picture of the moon. I think this was probably the day after or day similar with her Google Pixel and her 10-inch Dobsonian.
Oh,
and she's
Earthshine.
She's done it so she's got some Earthshine with it as well.
That's lovely.
That's amazing. Well done, Sonia.
Yeah, it could be a bit difficult to process the brightness differences between the dark and the daylight side, but she's got something there.
Yeah.
And there's another one that she's done, which was Friday. I got that the wrong way around, but yeah, so that was on the Friday. So that one's
nice.
A day after. That was a day after. And here's another one where she's got the moonshine on this one as well.
Wow.
So that was the day before. So we've got Dave Garside, which he has got. I'm sure you'll recognise it. The Whirlpool.
Very good.
And from Manchester's Bortle.
Oh, that's nice.
7.
Well done, Dave. That's great.
Bortle 7. So it's just about 4.5 hours total time on that, and got some nice colours on that.
Yeah, beautiful colours. Absolutely. Well done, Dave. Thank you.
Well done. And there's one from me. I managed to get some good seeing a couple of nights back, and so I decided to do some close-ups. And these are what I got.
Wow.
Very nice.
They've come out quite
great, Roger.
Very clear on some of the details, and you've got quite a lot of detail on the reels and stuff that are on in the season.
Yeah.
So I
amazing.
Was quite happy with that. And then
I would have been
put the other camera on and got a slightly more wider view of what was going on the surface.
Have you sent these to NASA? They're going to need some good pictures to help them land.
They do stand zooming in quite well.
What about astronomy picture of the day, Roger?
Well, I've sent these into the Sky at Night magazine, so we'll see if I get any response back.
Yeah.
It's like Google Moon, isn't it? Like Google Moon.
Yeah.
I was quite pleased on that. Obviously, the seeing does help. Here we have a picture of our long lost Karim, and these are some of his pictures that he took of the something that went on in last week over the Americas.
So another one with a halo around his head.
Yeah, there seem to be a lot of things going on like that.
He's got his
good picture.
So he was doing some pictures with the Sea Star and with his camera, and as you can see, there's some pictures of the progress of the Eclipse.
Wow,
which he's managed to do quite
very
well.
Nice.
And he was obviously projecting something like a calendar onto a background there to get this effect. So. I don't know how he's managed to do. I don't know how he's managed to do it, but obviously something of that line. He's probably just poached some holes in some paper or something.
Yeah, it looks like a crescent moon, doesn't it? Itself.
Yeah. So and here's some of his pictures of the aurora and some of the prominences that were on display at that time.
Wow,
nice.
Look at those prominences; they're nice.
Yeah.
Lovely.
Yeah, and it'll be the first time for lots of people to actually see the colour of the prominences as well, let alone see them at all. So that was lucky for them to have. And this is what the Canadian press actually did over the progression in and out of the eclipse that he had permission for. Yeah. So,
I mean, it's like a bit of an optical illusion, doesn't it? As the sun gets darker, it seems to get smaller. You know, it's a bit of an optical illusion, isn't it?
Yeah.
So, very, very clever.
Very good. Okay, and that's what I have to show for this evening.
Excellent.
Thank you very much, Roger. That's absolutely brilliant. And thank you to all of you who have been sending in your lovely images. As ever, we do really enjoy looking at them. And please keep them coming. And if you don't know by now, here's the normal drill. Send your images, 1 image per email, please, to spaceodditieslive@gmail.com. Include some information about how you took it, and that's it. And you should get a confirmation from us back that we've received it. And if we have received it, we will put it in the gallery. If you would like your pictures to be included in this gallery on a Tuesday evening, please get them to us by the end of Sunday, so that we've got time to, or Roger or Rachel or whoever's doing the gallery that week has got time to put it all together. If you don't get it to us before the end of Sunday, you'll be featured the following week. So don't worry, all the images that you send us get displayed in the gallery at some point. So there we are. And we would also like to say thank you to all of those who've been buying us coffees. As always, if you would like to buy us a coffee, then you can do so by scanning this QR code, and that will take you to the relevant page. And any contributions towards our coffee are gratefully appreciated, because it really does help us to keep things on the road and develop the channel, as I said earlier. So there we are. Thank you to Roger for the night sky news and the gallery. What we're going to do now is go over to Keith. And Keith has got a bit of a quiz on for us this week. So Keith, what's this all about?
Okay, I've got my presentation up. There we go. Right.
There we are.
Yeah. There aren't a great many craters on the Earth's surface, because the geology of our planet is highly active and it resurfaces itself quite frequently. Nonetheless, we do know of quite a few now. But the problem has always been is when you see a circular or near circular object from an aerial photograph, or from that matter from a orbiting satellite, is it genuinely a crater or not? And well, tonight you're going to get a chance to have a go, as they say, and see what you think about some of the pictures that I'm about to show you. But in fact, actually, there have been cases of mistaken identity in the past, and this is a classic one, actually. This image appeared on the front cover of Nature magazine, which is a highly academic journal, and it purported to show a series of impact craters on the Pampas in Argentina. The one at the top of the picture looks like a classic round crater in an otherwise fairly level surface. And the two objects at the bottom there appear to be like what you might get if impacting object had sort of hit the ground at a very, very low angle, and may even have bounced off again, having made an impact. Well, the truth turned out to be rather different. And in fact, it wasn't very long afterwards before geologists chipped in and said, well, actually, no, these were wind scour features, that the soil had been scoured away by the prevailing wind direction over a long period of time. And in fact, actually, a quick look at Google Earth revealed that this is indeed the case. If you look at these, and you can see a series of features here on the Pampas, which I just got off Google Earth this afternoon, you can see a whole load of elongated water-filled depressions all over the surface. And they're more or less all oriented in the same direction due to the prevailing winds that created them. The thing is that unless we had a cosmic shotgun hitting the surface there, you can't really explain away that many holes in the ground as being caused by an impact of an object, or not usually anyway. The thing is that, there was obviously a lot of egg on face about this, because Nature is a respected publication, and they swallowed this article, which presumably was peer-reviewed, saying that these objects were craters, and in fact, they're not. And in fact, it's amazing, thinking back to my geological training in the past how many objects on the Earth's surface look like impact craters but aren't, and how often they are mistaken for such by astronomers who clearly don't have the sort of in-depth knowledge that the geologists do about what they're looking at. So here we go. We're going to take you through a series of objects. There may or may not be craters. I'll make it easy to start with. Here's object A. So all you've got to do is decide yes or no on that one. I'll give you a few seconds to have a good look at it. You might notice, by the way, it isn't entirely round. It's a sort of slightly square shaped. Come to that later. Okay, going up with object B then. Here's object B. This is an object that you will no doubt have seen before because it often got photographed from the space station or from the shuttles as they passed over it. And there it is at the bottom there. I should add, by the way, this picture has been false colored, so don't take those blues too literally. Everything's really brown out there where this was taken. By the way, I'm not going to say entirely where these places are because that kind of gives the game away. Apart from anything else, you can go and Google the names and find the answers. So I'm not going to make it that easy for you. Right, okay. Moving on to object C. Okay. Now, there we are. What do you make of that? That's a very odd looking thing, isn't it? And the question is this a pair of impact craters or if it's something else? Okay. And object D. Okay. I'll give you one clue. It's in Australia, but I won't say any more than that. And the question is, well, is that an impact crater or not? And then we'll move on to object E. And is this an impact crater? It's quite big, by the way. It's a few miles across, whereas the previous one was only about 800 meters or so across. Is this an impact crater? You can get some impression of the size from the fact there's some clouds in the background, as you can see.
Big then.
Right, okay, moving on then. We'll have a look at object F. Okay, now the picture on the left is from Google Earth, but actually I think it's a bit more obvious what it looks like from the picture on the right, which I took out of the window of an airliner. I was on the transatlantic route and I caught this out of the window. And it was still snowy, as you can see, which sort of reveals the shape a bit better. And the question about that is that an impact crater?
Interesting.
It certainly was very striking. I couldn't miss it. You know, I thought, oh, wonder what that is. Got the camera out. Anyway, moving on. Object G. Okay. Got the sort of right shape and everything else. The big question, though, and you can see actually, by the way, it is superimposed on the existing geology. You can see some strata running through the picture from left to right, and this object has gone through them. And so the question is object G an impact crater? By the way, the yellow thing's a road, of course. And I think this is the last one. Yeah, object H. This is clearly filled with water, as you can see, and it's quite big. The question on that one is that an impact crater, or is it something else? Okay, folks. Well, there you go. We're going to leave it there, and at the end of the program, we'll let you know.
Thank you very much, Keith. So,
and one more thing, I'll explain why the non-craters are non-craters. I promise you, I will explain it.
Right. Okay. Well, thank you very much. We hope you got your head scratched there. So have a think about those, and Keith will reveal all at the end of the program. So what we're going to do now is to move on to this week's news and some as ever, there's some really fascinating stories in this week's news. So just give me a second to get myself sorted out here, and we will have a look. So, firstly, headline news. This was an amazing story. This concerns a Magnetar that has come back to life. Now, that doesn't sound incredibly interesting, but let me explain. First of all, let's just tell you a little bit, in case you don't know, about Magnetars. Magnetars are a type of neutron star. So these are city-sized objects, the most perfect spheres in the universe, apparently. And they are distinguished from normal neutron stars by the fact that they have intense magnetic fields. And when we say intense, we mean it, because magnetars have magnetic fields that are so strong they could pull the keys out of your pocket from the distance of the moon, and also wipe your credit cards for good measure. Of course, being neutron stars, these are ultra dense stars. 1 teaspoonful of a magnetar would weigh millions and millions of tons. So these are among the most bizarre objects in the universe. Why they're so magnetic? Nobody really knows. What's their story? Nobody really knows. How common are they? Nobody really knows, because to date, only, I'm a mine of information. To date, we've only discovered about 30 magnetars in total. But we suspect that there are many, many, many more. And the reason for that is that they are strongly suspected as being responsible for the very strange and enigmatic fast radio bursts that we see going off all over the sky all the time. These are intense bursts of radio energy that last typically for a few milliseconds. Some do it once and then are never seen again. Others repeat in all sorts of strange cycles. So magnetars are exceptionally strange. They're also exceptionally dangerous. If you got within about 600 miles of a magnetar, the strong magnetic field will literally dissolve your atoms. So these are, along with black holes, the most dangerous objects in the universe. Don't get within 600 miles of a magnetar, because you will quite literally dissolve and your atoms will fade away to nothing. So these are exceptionally dangerous objects. This particular story makes the whole phenomenon of magnetars even more bizarre, because it's come back to life. Now, let me explain. This was a magnetar that was emitting radio pulses in a regular rhythm, and it then died away, and it came back to life a whole decade later, just about a decade later. And this is a city-sized neutron star with the memorable name of XTEJ1810197. It was born, as all neutron stars are, from a supernova explosion, but this one is very strange. And the reason for this is, we think, that these magnetic fields get twisted like the sun's magnetic field does. And they twist themselves into knots and then, for want of a better word, snap, which releases enormous quantities of gamma rays, X-rays, and radio waves. Now, the history of this object, it was first discovered as a bright source of X-rays in 2003, and it was found to emit powerful radio pulses about every 5.5 seconds as it rotated. So the radio pulses were quite obviously coming from one spot on its surface. We don't know why. The pulses faded, and within 2 years, within 2005, it had disappeared altogether. But then, in 2018, astronomers found that it was emitting these pulses again. And the pulses were circularly polarized. Now, normally with these types of neutron stars, the polarization is linear. So something was twisting, if you like, the polarization into circular polarization. And astronomers think they've worked out what it was. And the fact is, the circular polarization is caused by the fact that this particular magnetar is wobbling on its axis after there was a star quake on its surface. Now, a star quake on a neutron star, being a perfect sphere, means that the surface was only deformed by about 1 millimeter, And that's about the tallest thing that can exist on the surface of a neutron star. But just this slipping of the surface by 1 millimeter is enough to release these enormous bursts of radiation. So this is like a Lazarus magnetar, if you like. And it's raised all sorts of questions because we don't know exactly how the radio pulses are generated. We don't know why it was quiet for over a decade before it came back to life. There's a lot we don't know. But the search goes on for... obviously.
I know.
Go on then.
I know the answer. Well, I think I know. So I'm going to make a prediction.
Go on.
The pulsar fades because we're not necessarily because it stopped emitting radio energy, but because we're not in its line of sight. If that's the case, and there was a 15-year gap between the time when it faded and it, as we say, it woke back up, then I would anticipate we would a similar kind of fading and wake up again in 2033. So let's stay on Space Oddities till 2033 and see if that happens.
What a great idea, Lou. So it's not 50 because it faded in 2005.
Okay.
And it was detected again in 2018.
All right, so 13
years, yeah.
Right.
Yeah. Okay.
So what's that, 2031?
2037.
37.
Oh,
All right.
No, if you take it from now, yes. But if you took it from the time it woke up again, then yeah. So we've got a few years to go anyway. But you know, if we weren't in its line of sight, if we dropped out of its line of sight, so to speak, what would be the reason for that?
A precession.
Just precession. Yeah.
Yeah, I think so.
Okay, so that's that was my story of the week, because this demonstrated, you know, these objects are so weird and so bizarre, and so little is understood about them because only about 30 have ever been discovered. Now, there are all sorts of theories as to how magnetars are formed in the first place, and the suspect are giant stars with these ultra strong magnetic fields that are preserved in the neutron star. But you know, that's just a guess, really, because we don't actually see the process happening. We have, of course, discovered a magnetar in our own Milky Way galaxy, and that one was the source of one of these mysterious fast radio bursts about 2 years ago, was it? Maybe a bit more. And so we know that these types of neutron stars, these weird magnetars, do emit fast radio bursts, because we've detected one coming from the one in our galaxy. Unfortunately, it hasn't repeated. It's one of the magnetars, if that's what they are, whose radio transmissions have not repeated. So it was only one burst that was tracked down to an object that was later identified to be a magnetar. So we will see. You could well be right, Lou. So there we are. Anyway, that was a weird story of the week, definitely. And here's an artist's impression of what a star quake on a neutron star might look like. And it's that comes from NASA Goddard and S. Weisinger. So thank you for that image. As I said, just a slip of a millimeter can cause these cataclysmic bursts of radiation to be released, and you just can't comprehend how much radiation that is. It's crazy, just from a surface subsidence, if you like, of 1 millimeter. And we could go on about these forever, but we really don't know much about what's inside a neutron star. It gets crazy, that's for sure. There are exotic forms of matter, it is believed, inside neutron stars that you will not experience anywhere else. And there are lots of simulations and theories, but of course we don't know, and we probably won't know for a very long time unless something very unusual happens. I'm hoping that one of the gravitational wave events of a neutron star being consumed by a black hole, which I think 2 or 3 have been observed so far in gravitational waves, that will give scientists some clues as to exactly what's in the neutron star. But the first one that was observed by LIGO, it seems the black hole swallowed the neutron star almost instantaneously before there was any radiation released, before any radiation had a chance to escape. So we didn't end up knowing that much about the neutron star itself. It just was consumed almost instantaneously. I think astronomers were hoping that it would be a little bit of a prolonged process and the neutron star might emit radiation as it was consumed that would tell us about the inside of the neutron star, but it wasn't to be. However, anything's possible in the wonderful, wacky world of astrophysics. So there we are. Okay, now moving on, we've had a record-breaking black hole discovered in our Milky Way galaxy. This is an artist's impression of what the system looks like. You can see the black hole there towards the bottom. It's orbited by an old star. And let's have a look at this. Why is it record-breaking? Well, first of all, it was discovered in data from the unbelievably wonderful Gaia probe from the European Space Agency that, as you may know, has been patiently mapping stars in our galaxy with great precision. And they were preparing the Gaia data for publication because there's a new release of Gaia data due. And one astronomer noticed this in the Gaia data that hadn't been spotted before. Why is it a record breaker? Because it's so massive, because this is a stellar mass black hole that weighs in at 33 solar masses. So this is a real heavyweight solar masses. And it's more than the previous record holder for masses of solar mass black holes, which is a mere wimpy 21 solar masses. So as far as solar masses go, this is a real heavyweight black hole. And it's the heaviest solar mass black hole so far discovered in our galaxy. It's very close as well. It's only about 2,000 light years away in the constellation of Aquila. It's the second closest black hole to the Earth so far discovered. There's one slightly closer at about 1,800 light years, but astronomically, this isn't even down to the corner shop. This is just next door. This is your bad neighbor next door. So very close. It was detected by a wobble in the orbit of that star that's going around the black hole. This is how it's detected. The star is metal poor.
It's an old star then.
Yeah. Now, the idea behind this is that when you have a black hole and a metal poor star, it's assumed that the star that was the progenitor of the black hole was also metal poor, because stars, of a likeness cling together, or whatever the saying is.
And they tend to form in pairs more often than not.
That's right. Now, because of this, they think, as I said, that the progenitor star was probably the same composition. And what this means is metal poor stars over their lifetimes lose less mass than the stars with more metal. By the way, we ought to define the term metals here. To a scientist, a metal is anything that is heavier than hydrogen and helium. So it's not metal as we would imagine it, like steel or iron or aluminium or something. So these are elements that are heavier than hydrogen and helium. And because they lose less mass over their lifetimes, when the star collapses into a black hole after a supernova, there's more mass to go into the black hole. So this is the theory as to why this black hole is so massive, because it comes from a metal poor star. So there we are. So a record-breaking week for black holes in the Milky Way. Moving on, the Indian Space Agency has been commissioned to launch an important European solar mission. So ISRO has bagged this one, and the mission in total to be launched later this year is called Proba 3. Has anybody heard about the Proba 3 probe?
No.
Oh, okay. So Europe are launching a spacecraft called Proba 3. It comprises 2 spacecraft which are going to study the solar corona in unprecedented detail. Now, the solar corona is the sun's atmosphere, and it's that bit you may have seen in the eclipse, round the edge of the sun, the bit that glows, the wispy bit. And that's the atmosphere of the sun, which we can only see, of course, during an eclipse. Otherwise, it's too bright. And launch for this is scheduled for September. Now, this is quite an interesting mission because it comprises 2 spacecraft placed into a highly elliptical orbit. And this is what happens. The first spacecraft casts a shadow over the second spacecraft. In other words, it's an artificial eclipse of the sun, allowing the second spacecraft to have a look in detail at the solar corona. Now, whereas a normal eclipse, as we found out a couple of weeks ago, may last 4, 5, 6 minutes, this configuration, each time they do the observing run, will last for 6 hours. So there's a lot more time to actually study the corona. So this is a really exciting mission for Europe because we stand to learn a lot more about the corona, because there are still lots of unanswered questions about the sun's corona. So that was interesting that the European Space Agency has been chosen to launch that. This is an indication of course, the success of ISRO, the success of the Indian space program, and the reliability of their rockets, which have chosen to be really, really reliable. And Europe has placed their faith in India to launch that Proba 3 mission. Now, we've talked a lot about the eclipse tonight and last week as well, and we'll talk about it again next week, I'm sure. But does anybody know which planets in the solar system can experience total eclipses? Which planets can you go to see total solar eclipses? Does anybody know?
I would say none.
None?
Yeah, I can't think of any.
Earth.
Well, about the Earth, that's one.
Yeah.
Oh, if you came to the Earth, yeah.
And you're absolutely right.
One.
The Earth is the only planet in the solar system that experiences total solar eclipses. And that, of course, is only a temporary phase as well, because as the moon gets further away from the Earth, then we'll start experiencing annular eclipses instead of total eclipses, and so on and so forth. So I thought it might be nice to remind people that although there are no total eclipses visible anywhere else in the solar system except on Earth, Mars has eclipses too, but not total ones. And this is a video from the Perseverance rover showing an eclipse of the moon Phobos passing in front of the sun, and this is actually what it looks like.
Yeah.
Got some nice sunspots there as well.
Absolutely.
I think last time we showed this, somebody did actually pop in and say, well, if it's not a total eclipse, I mean, it is an eclipse. They say, but is it more of a transit? It's one of those things. It's, tomato sort of thing. Is
one man's transit is another man's eclipse.
Exactly. Well, transit is an eclipse, isn't it? If you think about it. So yeah. It's,
answers on a postcard, please. So I thought worth showing that again because
it's lovely
to remind people that you can see eclipses from other planets in the solar system, but not total eclipses like the ones that we see here. And another discovery this week, a new microgalaxy orbiting the Milky Way. Here are 2 star fields. The one on the left is with all the background stars in, and the background stars have been removed to reveal on the right what's being called a microgalaxy, a group of stars orbiting the Milky Way, the newest so far discovered, and I believe the smallest. Because what's the gen on this? It is the smallest microgalaxy ever found orbiting the Milky Way. It's designated Ursa Major, which is where it is, 3 unions 1, and sounds like a football score. Ursa Major 3 unions 1, and it comprises 60 stars, which are about 10 billion years old, in a region spanning just 10 light years. It's got a total mass of 16 solar masses. It is thought to be dominated by dark matter based on the spread of velocities of its stars. So this is the newest addition to the list of satellite galaxies, in this case a microgalaxy, that are orbiting the Milky Way galaxy. And it was discovered, just as these things often are, purely by chance. Nobody was looking for this, and somebody spotted it in the data. So the Milky Way has a newly discovered companion dwarf galaxy called a microgalaxy, and presumably at one point it was bigger and has been torn apart. We don't know, or it might have formed like that. So it's early days yet for this particular discovery. So that was quite remarkable this week. Where do we go from here? We go to Curiosity, because Curiosity is following the water on Mars. It has arrived at a place thought once to be a valley that filled with water billions of years ago. And let's have a look at the details. Now, here's the situation, and the yellow line represents the path that Curiosity has been following to get to this point. It's almost certain, if you look at that, it's not a very good image, I'm afraid. It's the best I could find, though. You can see that it looks very much like a river channel, and this is where Curiosity has ended up. And it's thought to have been carved by water, and it has the name of Gedith, or Gedith, it might be Spanish, Vallis. And it's thought to have formed after a dry period preceded by a wet period. So it's been alternating between dry and wet. And the rover is going to study what formed, or try to study what actually formed the bedrock. Was it water, or could it conceivably have been something else? And don't forget, Curiosity has been exploring the Martian landscape now for 11 years. Doesn't seem possible that it was 11 years ago. So interesting information to come from this study of what is believed to be an ancient riverbed, this Gedith Vallis. We'll look forward to the data from that. Moving on, this is it's been a week for firsts in the universe. The first detection of light coming from a rocky exoplanet. The exoplanet in question being one we've talked about several times on Space Oddities, that is Trappist 1b. And the story here is that the James Webb Space Telescope has detected infrared emissions from Trappist 1b. It's the first time any light, any type of light, in this case infrared light, has been seen coming from a small rocky planet like the Earth. And this planet is it's very strange because it has no atmosphere. We hoped that the Trappist planets would turn out to have atmospheres and be like the Earth, because they're all about Earth size, give or take. And we hope they might have atmospheres and they might be good places for life. But Trappist 1b, which is the closest one to the red dwarf star Trappist, it's not called Trappist though, is it? I can't remember what the star's called. It has a designation. But anyway, it's definitely not a place for life. No atmosphere, and the surface temperature is about 230 degrees Celsius, so an inhospitable place for life to get started. It's actually orbiting just 1 million miles from the star. Now, don't forget that these red dwarf stars are a lot smaller and a lot cooler than a star like our sun, so planets can orbit that close to the star without being consumed, and it takes about 1.5 Earth days to go around its star once. So it is very close to its star. And here's the Trappist 1 system, which we've talked about before. You can see B being the closest to its star. In this type of designation, A is the star itself, and then the planets are subsequently labeled B, C, D, etc., etc., etc. So this was a first for astronomy, the first infrared light coming off a rocky planet like the Earth, and actually almost the same size as the Earth. And you can see here that Trappist 1D and Trappist 1E are a bit smaller, and H, but several of the others are almost exactly the size of the Earth. So the hope has been that these are prime candidates for where we might find life. But the more data that the Webb returns and is analysed, we realise that actually so far we haven't found any of those planets to be suitable for life. But there's a lot more observational data to come from the Webb. So fingers crossed for that.
I think, by the way, if you were to put our solar system on top of this, I think the Earth would be orbiting somewhere between the F and G planets of Trappist.
Oh, right. So they're a lot closer, obviously. Yeah, thank you for that, Lou. Mm-hmm. Now, we have another first regarding an exoplanet. This is exoplanet WASP 76b, and for the first time, a glory has been observed on this planet. Now, how on earth was this done, and what exactly is a glory? Well, let's have a look at the facts for this. It's a phenomenon very much like a rainbow, although subtly different to a rainbow. On WASP 76b, which is an exoplanet 736 light years away. Now, you might say, how can you possibly see a rainbow on a planet that is that far away? Well, let's have a look. So this was discovered in a series of observations, transits, in fact, across the surface of the star, much like Phobos did across the surface of the sun earlier on Mars. So we can classify that as a transit, same sort of thing. And it took 3 years to pull this information out of the data, during which time there were quite a few transits. Now, what this showed up is they were observing the edge of the planet as it transited, and on the eastern border, between the day and the night halves, there was an enhancement in the light. So there was a bit of extra light there. And the leading theory is that this could be caused by a strong localized, directionally dependent reflection, otherwise known as the glory effect. This is what the analysis demonstrates. And in case you're wondering, this is another inhospitable planet. The planet's surface is extremely hot, 2,400 degrees Celsius. So again, not a place for life. We believe it's tidally locked to its star. That is to say, it always keeps the same side facing the star. And another weird thing about this planet is that it rains iron. The way that this works is that it's so hot on the sunlit side that metals like iron on the surface are literally boiled off and form a metallic vapor, which then travels to the night side, rapidly cools, of course, in the sub-zero temperatures, condenses and falls out of the sky as droplets of iron. So this is a really weird place where it rains iron. Lou, I was going to ask you about this. It's just something that occurred to me. Any idea what the transport mechanism would be for getting that from the day side to the night side?
Well, perhaps. So you mentioned that so how far away is it from its star? It's tidally locked.
Yeah, it's tidally locked. I'm not sure the exact distance, but it is tidally locked.
So if it's tidally locked, it rotates once every orbit. So it's a very slow rotator, and you could easily have, say, one what you would call Hadley cell, which would kind of take the entire atmosphere from one hemisphere and move it to the next. Yeah. Now, I don't know how this works longitudinally. Latitudinally, I think I get it, but I think what you're saying is longitudinally. So there have to be some sort of winds that would, like we see on Earth and other planets, that would provide the dynamical energy to move them, but probably very slowly, I would imagine.
But, I think we've seen this before, haven't we? That where you get an intensely hot side and an intensely cold side, that alone is enough to generate high-speed winds, isn't it? Or can be.
Well, let's see. What do we know that has that? Venus is hot, but it's hot all over the place.
Yeah.
Mercury has nothing to speak of.
No.
I'm not sure what example that you would.
No, I'm sure. I'm sure there's been an exoplanet discovery where these high velocity winds caused by the temperature differential will be whizzing around the planet. I'll see if I can dig it out because
I think there was one where again the same as this. I don't know whether it's the same planet actually. Is that it was there? It was so close to its sun that the rock and all the minerals melted, and it actually formed part of the atmosphere.
Yeah.
And of course, if you've got differentials of temperatures, you are going to get some sort of convection.
Sure.
Movement of the actual atmosphere. And of course, as you said, as it comes to the night side where it's cooling, the other one, it literally rained lava down on top of you.
Right.
So
so it's going to be a fairly thin atmosphere then, right? Because
they're very, very thin. It's negligible, literally, the atmospheres, but then the actual once the rock and the elements sort of like melt and atomize, then they form the atmosphere.
Yeah, absolutely.
So that's the actual atmosphere that would be moving.
Yeah.
It's a very strange, very, very strange thing.
Yeah.
Wouldn't want to be there on holiday.
No, not if it's raining iron. Definitely not. So there we are. So this just goes to show that, you know, there are some weird places in the universe, and we haven't really scratched the surface yet either. Anyway, in case you're wondering what a glory is, these are two images of glories. One's a glory surrounding a plane, and the other one is a person. And this is an optical phenomenon. It's like a rainbow, as it says. It's the refraction of light through water, or ice crystals, in fact, in the atmosphere, as it probably is in the case of that plane. But it appears as a series of concentric iridescent rings around the subject, a person or a plane. And it's different from a rainbow because it's smaller and more localized, and is a bit more subtle to see. So just thought I'd show you what a glory actually looks like. And the fact that we've observed, apparently, if the data checks out, we've observed one of these on an alien planet is just absolutely mind-blowing. It shows how far the science is progressing. So that was great. Okay, then the last story this week, you'll be pleased to know that the camera for the Vera Rubin telescope is complete. And there's a technician in front of that camera. This is the world's biggest ever digital camera to be installed at the Vera Rubin Observatory in Chile. And let's have a look at some of the information here. It's got a resolution of 3,200 megapixels, so extremely high resolution. It's going to be installed at the observatory later this year. Weighs around 3 tons. As you can see, it's a real monster. The observatory, and it is a revolutionary observatory because it is a wide field survey telescope that's going to work in a way different to any other telescope that's ever been. And it's expected to see first light next year. Sometime we'll do a little bit of a special about the Vera Rubin Observatory because it's going to be a very special instrument indeed.
You're going to need a bigger tripod.
Going to need a bigger tripod, yes, definitely. And there you have the technicians standing in front of it. And also, here's what the Vera Rubin telescope currently looks like. It's nearly complete, and they're just about ready to install the camera, which those technicians quite rightly are standing proudly in front of. So we'll look forward to first light from the Vera Rubin Observatory in Chile next year, but we will talk about it a lot before then, I'm sure. And that, ladies and gentlemen, brings us to the end of the news for this week. So there we are.
Thanks for that, Andy.
No, there's some, as you can see, there are some really, really interesting stories there. Just let me get rid of this, and there we are. So there we are, and it always goes back to Michael. Always hogs the frame. Yeah. So let's just fix that right.
Well,
now.
he is the only one wearing a Space Oddities shirt.
Yes, absolutely.
Just floating around out there.
So there we are. Right. Well, Lou, if you would now, if you're ready now, if your presentations are all systems go, then perhaps you would talk us through your experiences of the eclipse.
Yes. Let's. Okay, so before the eclipse, I want to take just a minute to give a Voyager 1 update.
Oh, great, thanks.
So as our listeners know, they've been having trouble at Jet Propulsion Laboratory communicating with the Voyager 1 spacecraft. It's started sending back kind of what appeared to be random ones and zeros, and they didn't know what that was. They could send commands to the spacecraft, but what they got back was unintelligible. So around the 1st of March, they sent a command to the spacecraft. 22 and a half hours, by the way, is the one-way light time there. So almost a day. And they said, send us a map of your FDS, your Flight Data System memory. And the Flight Data System is the computer on board the Voyager that collects the science data, which are the observations from the instruments, and the engineering data, which is the status of the spacecraft, temperatures, voltages, things of that nature, and then sends them to the telecommunication system. So Voyager 1 responded, and it sent back something very different than it had been sending. By the way, this is the first volatile memory that was ever used. It's 50 years old. First volatile memory that was ever used in a spacecraft. So they got these somewhat different ones and zeros and pinpointed the location of the bad memory in the FDS computer, the Flight Data System. And it turns out they believe that it's a single chip that isn't working, either because it was hit by an energetic particle, right, or old age. But regardless, they are now working on seeing if they can isolate that bad memory piece and get the FDS system to work using only the rest of its good memory. And this will take a while. It's not, it's not straightforward. And in order to do this, they have to pour through reams of 50-year-old paper documents, wherever they can find them, to figure out what the memory map should look like and just the status of the spacecraft. So, but there is now hope. So there was no hope, or very little hope, a few months ago, and now it looks like they may have a path to solving the communications problem.
Okay, then that's good.
Yep.
Yeah, because was it Spirit who was the sister or brother of is it Opportunity?
Yes.
That started to have memory problems and started to do sort of the same sort of thing towards the end. And as you say, it's old age. It comes to us all, unfortunately. It kept forgetting things. So, yeah, these things happen. And, of course, there's no one there to give them a clout.
No.
Yeah.
So it's miraculous, I think.
Yeah, always.
And this is a story that has happened a few times with Voyager and certainly with other spacecraft. These ground system crews work miracles. So let's stay tuned and see if they're able to bring it back to life. I really hope so that it's alive.
Well, I mean, understanding the problem is the first part of solving it, isn't it? So, it would have been disastrous if they had found no explanation for it. But, perhaps they can work around this chip, bypass it in some way.
And, of course, the coding's so old, they have to bring people out of retirement to...
It's so old, it's written in Latin.
Chipped into stone tablets on the spacecraft, I believe.
Chips.
I mean, chips don't last forever. I mean, the chips on my telescope's computer have dried out and died after 20 years. So, so they don't last forever. And I didn't even last as long as Voyager. I want my money back. So so there we are. Right, thank you for that update, Lou. Keep us posted on that, and we'll see what happens. And, it would be wonderful if both the Voyagers could get to their 50th anniversary. That would be a real achievement. And
NASA is already planning big parties.
I'm sure. They invite us.
Yes, so, you're invited. You're invited.
Yeah. So anyway, please continue.
Okay, so let's go on to the Eclipse. Now, as our viewers know, I was having real trouble uploading the file that I had. So I slimmed it way down, took the slimmed down version, just the slides that you absolutely have to have, and broke it into 3 parts, and I was able to upload it. So this Eclipse, I went to Southern Illinois University in Carbondale, Illinois, at the southern tip of Illinois, to not just watch the eclipse, but to share the eclipse with the rest of the country, the rest of the world. We had an amazing team there. I'll show you a picture of them in a few moments, from Southern Illinois University, certainly, where we had great communications and leadership teams. NASA Edge was there to stream part of the eclipse. We had Johns Hopkins Applied Physics Laboratory that was there representing the Parker Solar Probe mission and other solar missions. And just a whole fleet of people that were there to try to broadcast this eclipse to the world. We had a stadium that was sold out. I think they sold 45,000 tickets to the stadium. So most of what happened for me was inside the stadium with about, I think we had a little over 100 news groups there, from the Weather Channel to CNN to all kinds of local and regional groups doing interviews. So I spent some of my time doing that. And so I'm just going to share some pictures with you. So here we have our website. And by the way, that website, we are storing images of the eclipse, and we will migrate that site at some point to a site called Solar Steam, and that will have more heliophysics events in it. So let's see. So here I'm just going to jump quickly to some images that I took.
Wow.
This is weird thing is, if you looked at the cloud maps for 2, 3, 4, and so on months before the eclipse, it was clear that Texas was the place to go. Texas and Mexico, clear skies assured. And in fact, Texas had a tough go of it. Many people who went to Texas didn't see the eclipse, but we had pristine skies in Carbondale, bracketed by cloudy, rainy weather on both sides. So if the day had shifted one way or the other, we would have seen nothing. But it was really spectacular. So this was taken with a 70 millimeter stellar view refractor with a white light solar filter and a 70D Canon camera on the back end. Nothing too fancy.
Wow, diamond ring.
And here's the diamond ring. Yeah, this is I think post eclipse or post totality, the diamond ring.
Wow.
So we were going crazy. Imagine a stadium of 45,000 people all jumping up and screaming and yelling and crying at once. It was rather dramatic. So I think that is all I put in this first slide. Yeah. So if we could go to the next one, I think it says short 2 on it. There we go. So here's a picture of part of the stadium. These were images that we put up on the big screens there of the eclipse from various locations along the path. We had 100 or more telescopes, almost all of them along the path of totality, viewing in white light, calcium K, and hydrogen alpha. And so you're seeing, obviously, at the same time here, you're seeing eclipse images from different places in the path, starting with Mexico.
Wow. Amazing.
So let's see here. There we go. So I mentioned that Texas had a tough go of it, but in Southern Illinois, we just had this little clear patch. This is the weather on the day of the eclipse. So we just got damn lucky and had a clear patch around us to view the eclipse, and many other places did not. Although Maine and parts of Canada, I think, had a really good clear skies.
You're a star.
Yes. So it was interesting. I did this kind of thing for the 2017 eclipse. I guess I'd kind of forgotten. sometimes the day's schedule said, okay, so-and-so, you're on for an interview at this time. Lou, you're on for an interview at this time. And sometimes it was, Lou, quick, we need you on camera. You've got 1 minute. It dragged me, running across the field. So it was, it's exciting. It's fun. And I got to talk about the eclipse, which is what I love to do.
Fantastic.
So here's the next slide. So that's my little setup, just trying to catch a glimpse of the sun just as it's rising. So obviously this is before the eclipse, and you see in the distance there, you see my little sea star, which actually belongs to my university. And it took some rather good images, although we had a little trouble with the pointing right around totality. But, we had a backup system. Oh, and the stellar view here is on a Skywatcher Solar Quest mount. It operates somewhat similarly to the sea star. You essentially set it down, level it, and push a button, and it finds the sun and tracks it. It's really remarkable.
Amazing.
Yeah, I've got one myself, Lou, which I find very good. Yeah.
I mentioned this is called, our project is called DEB, and I forget what it stands for, but I think the E stands for Eclipse. And so these are the telescopes these are identical telescopes that were purchased for these volunteers from Mexico to Canada. And so they've collected the images, and there is some science that can be done on it, looking at the structure of the corona.
Amazing.
So just a couple more slides here. This is a good portion of our team that we had out in Carbondale. You see representatives here from the Adler Planetarium, who I neglected to say they were on our team, producing planetarium programs and helping out in the stadium. NASA Edge here, the guy who's kneeling right in the center with the glasses on, the short guy. That's Blair Allen. He's the co-host of NASA Edge. To his right is Troy Klein, who's the education lead for Parker Solar Probe and Dragonfly missions at Johns Hopkins.
Wow.
There's me to the right or left of me, depending upon your orientation, is Franklin Fitzgerald. He's also with the NASA Edge group, and just a number of other people from NASA Goddard and SIU who just put on a remarkable show. And we're excited to get the data and see just how many people we reached and what our impact was. So one more. Oh, maybe two more. This is a little contraption called a sun funnel. And this is something that I helped design with a couple of other colleagues here in the States. And it's a very simple piece of equipment. It's an oil funnel. If you put oil in your car, assuming you don't have an electric car, put an oil in your car, you get this plastic sun funnel that's wide at the top so you don't spill, and thin at the bottom. And yes, thank you, Dynamic Eclipse Broadcast. Thank you, Ian. And you cut that oil filter at the thin end just at the right place so you can fit it over a 1 1/4 inch eyepiece. And on the top part, you stretch a piece of rubber. So you have a nice projection device for the eclipse. Makes it very easy to see the eclipse for multiple people.
That works well. That's a really bright image as well.
Yeah, it was bright and very high resolution, surprisingly high resolution.
Wow, that's amazing, Lou. Well done.
And so so that's it for that. So if you could do the collage, if you could pull that one up.
I'll let you do the honors, Andy.
Okay. All right.
So this is the kind of a collage of images of the eclipse taken with a stellar view. And it was surprising how easy it was. Fortunately, my wife Susan was with me. She's becoming quite an amateur astronomer herself. I can't believe I agreed to do this. I was on camera on SIU radio or podcast.
You've got a great face for radio, Lou.
Yeah. During the eclipse. And the reason I was on camera is that they asked a couple of other people, and they said, I'm not doing it during totality. I'm looking at the eclipse. So while totality is happening, I'm being interviewed, and Susan was back there snapping pictures and making sure that all the images came out. So this is these are her images, but it turned out pretty well.
They're beautiful.
Yeah, that's brilliant.
Yeah,
nice. Yeah,
It is good. Yeah.
Can I just point out this the actual total eclipse in the center? If you look at the corona between the sort of like 6 o'clock and 7 o'clock areas, you will see that the corona has a big dimple in it. And I'll be talking about that in a minute.
Oh, wonderful.
Okay.
Wonderful.
Uh-huh.
Right. Well, listen, Lou, you can tell Susan from us she did a fantastic job.
Lovely job.
Those are really good images.
I will pass it on.
Yeah.
And get her to come on Space Oddities as well.
Yeah.
Okay.
You should come on and have a chat. We'd love to have a chat with her.
Yeah.
Will do.
Yeah, okay.
Yeah, the woman behind the man.
Okay. Right, well, listen, Lou, thank you ever so much for that.
Mm-hmm.
And we will just get rid of these as well. And no, I didn't want to turn Lou off. I wanted to turn Neil off. Okay. Right. Okay. Oh, back to Michael again. Oh, God, every single time.
Just show hog, Michael.
Well, I'm next anyway on time.
I don't know. I can't remember from the running order where. Oh, yes, absolutely.
Michael.
So,
Yeah,
Michael, tell us about the science fair.
Right, just bear with me a second. Okay, I'm here to tell you about a science fair happening on Saturday, the 11th of May, between 10 a.m. and 3 p.m. at Purton Library near Wolverhampton in the West Midlands. This is being run by Purton Library. There's going to be lots of different stalls there. Have you got the slide up, Andy?
1 second, Michael. Yes, I can do that with pleasure. If I can find you. Okay. Okay. Right. Yes, got it.
Yep, you can see there's quite a few different stalls there, various organisations. For instance, Staffordshire Wildlife Trust.
Okay, so that's free entry as well.
STEM Outreach. Entry as well. Wolverhampton Astronomical Society are there. Also, Purton Library Astronomy Group. And this comes from Kath Adams, who's the president of Wolverhampton Astronomical Society.
Fantastic.
Yeah.
So that's free entry on Saturday, the 11th of May. All welcome. Go along and have for some fun.
So that's Purton Library.
Yeah.
And it's in Staffordshire, obviously. Yeah. Where did you say it was in Staffordshire, Michael?
Near Wolverhampton.
Near Wolverhampton. Okay.
Yeah.
So I'm sure if somebody Googles Purton Library, they'll find it.
Yeah. There's an email address at the bottom there.
Right. Do they have a website or not?
Good question. It's not advertised on there, actually. So
no, I guess not.
But do a search on Purton Library. I'm sure it'll come up on
Purton, P-E-R-T-O-N. Thank you very much, Michael.
Okay.
That's absolutely fantastic. So there we are. So that looks like a good day out for all the family.
And I'm here again.
And you're here again. So let's just rectify that sad situation. And there we are. Okay, move on. Well, we've been talking a lot about the sun, about the eclipse. Lou, thank you so much for your wonderful presentations there. So, Daz, I gather you're going to tell us a little more about what's going on.
Yeah, well, there was a bonus. And as I said, I pointed out to, now I hope this works. I really do. I'm just going to share my screen. Go big. Right, here we are. Now, this isn't as good as Lou's image of the actual total eclipse, but as we know, when the total eclipse happened and we saw Karim's lovely image of all the prominences, we know that there was a big prominence at about the 5 o'clock position. And this here, you can see this is in visual light. You can see that there is actually a very bright spot at about the 5 o'clock on the actual sort of edge of the sun. Now, if you look slightly to the left of it, you can see there's a dark line. And then there's this sort of like a little cavity that's digging in to the actual corona.
Yeah.
Now, luckily, some people actually noticed this and they thought, oh, hang about, what's that?
It's not beige,
And
is it?
what they did is, I'm going to have to go to up here. Sorry, hang about. Wait, just bear with me a minute. So what it is you can actually see, like I said, you can see the cavity. And what it is, what we will do is they then turn to space telescopes, and then this is what they saw. They zoomed in onto the prominence, and as you can see the prominence all proud above the actual surface of the sun.
Wow.
But can you notice that curved shape at the bottom?
Yeah.
Okay, then. So what that actually is, and what I'll do is I'll zoom out. One more. There it is. You can see it there.
Yeah.
And what it looks like is it's actually connected to the actual prominence itself. And basically, now this has been seen before, and this is where it gets a little bit silly. What people used to say it was is that the actual. Can you see my cursor?
Yes.
Yeah. Where the concave part is, they were saying this is a spaceship.
Oh no!
Yeah.
No.
And you can see it's actually joined to the prominence, and there's a tether going all the way down, or a pipe or something going all the way down to the sun, and it's actually drawing off the sun's plasma because that's what it uses as fuel.
Yeah.
So this is aliens stealing our sun.
Aliens.
No.
Yeah. Of course, what it was. This is what it was. This is what they thought it was, and of course, we often when we see them, it still raises its head. I'm surprised it hasn't appeared so far. But what's happened is what this actually is a solar storm that's yet to be launched. Now, you remember that in a solar storm, you have what they call a magnetic flux rope, and of course, once I mention that. If you just bear with me a second, I've just got to come back over here. I'm going to stop sharing for a second.
And I thought it was the planet Vulcan.
And what it is
I thought it was Daz's head in the way.
Let's have a look. Let's see if we can get me big. That'll be nice. No, we can't. So basically, what it is, it's slinky time.
Oh God!
It's slinky time.
Dr. Slinky.
As you can see, hey, I'm getting me money's worth out of it. What it is also the magnetic flux rope, which is the core of a solar storm. But why we're seeing it there is it hasn't launched yet. It is still tethered to the sun. And so the way we're seeing it is we're seeing it down the hole there, like that. So it's still actually tethered to the actual sun. So I'm just going to go back again. So the Slinky has had its day out again. Yeah, so there we are. And as you can see, if you look at the solar wind coming off of the sun to the right and to the left a bit, you can actually see it's beginning to curve round. And that will be running across the top of this Slinky. And it will be basically encasing it and holding it down. But of course, if that did launch, because it's on the it was on the sort of like southwest, it would have launched away from us, so we wouldn't have actually seen it go. But that's what it is. That's the actual silhouette of the magnetic flux rope waiting to be ejected out into space. So you're seeing a solar storm in the making there. So I don't know whether it actually did launch off at the time, but that's what you're actually looking at. And it was just because somebody noticed that there was this hollow in the actual corona, and when they looked at it in space weather, that's actually what it was. Now, just a couple of other little things. It won't take 5 seconds. I've just got to go back up here. This is to operate this. So what we've got here is we've had a couple of solar storms hit us on the Sunday, Sunday and Monday. And what this is, I'll just play this. This is only 10 seconds. And what it started on, let me get this right, the 13th, and it carried, it started on the 14th and it carried on into the 15th. And this was it was a double whammy. And I'll just start playing this. You should be able to see it's moving. It's only 10, 15 seconds long. But if you look at the center, just above the center, all of a sudden you will see whoomph. There it goes. Now you can see most of it was directed to the east of us and to the north. But there was a big component that actually came towards us. Well, that was actually followed later in the day by, if I can get this to advance, another solar flare. Now this one, what you have to do is you have to watch the center, but slightly just lower, just a little bit lower to the
where that flag is.
7, just a little bit to the right of that. If you watch it, I'm just going to start it. So we've had that first one go off. So here we go. I hope this is working for you all.
Yeah, it is. Yeah.
Yeah. So we'll see some other flares going on. See that big flare there?
Oh, yeah.
Yeah. That was going on. Now also go back to the east limb and look at all those arches, and bang, again another one went on.
Wow.
But that one that was towards the center is more Earth directed, and it's got some oomph behind it. So we've got 2 storms that came towards us. The first storm basically hit us midday. Then it sort of like started to tail off, and then bang, the second one hit us. But it was all during the daylight for us, so we didn't really get to see anything. Although they were possibly hoping that it would carry on into the evening, I wouldn't know because all I had was clouds. So basically, that's what's happened this week. Now, what we will do is I'll stop there, and if we got time at the end, I just want to tell you about another event that should be happening later this week. So hopefully,
yes,
but that was just what I'll point out that to that what they found actually in the corona.
Thank you very much. Very, very interesting. And this is a series of things that Daz is going to be doing about the sun. We've called them Daz's Dazzlers because they are about the sun, and
wasn't my choice.
Dazzling. So you know when you've been dazzled. So there we are. Thank you for that, Daz, whatever. So there we are, and Daz has got lots more to tell us about the sun as we approach solar maximum. I'm quite sure of that. Okay, so what we'll do now, we will get Keith to answer the burning questions that he posed us at the beginning of the program about which of his images are craters and which are other formations on the Earth. So, Keith, just give me 1 second and I will set you up again, sir. So,
yeah.
So there we are.
Right. Okay. Well, there's one person on the team who will know all the answers already, and that'll be Lou. But we'll go through them. Okay. Right.
Yeah, well, that one needs no introduction.
Yeah, absolutely. I'd be surprised if anybody failed to get this one right. This, of course, is the Barringer meteor crater in Arizona, which, due to the pre-existing geology of the area, didn't end up totally circular. As you can see, it has a slightly sort of square shape to it.
Well, what is the geology there, Keith?
Well, looking at it, the edges of the crater, I would assume it's some sort of bedded sedimentary rock, like sandstone or something like that.
Yeah, because there's 2 types, because it's left 2 types of rock.
Yeah.
There's rock that's been really seriously heated, which basically crumbles, and then there's a harder, but they have been altered by the temperatures. And I've always thought it's really lucky that it landed right next to that vacant visitors center.
Yeah, that's right.
That was fantastic. Yeah.
Yeah, that was a near miss, wasn't it?
Yeah.
Yeah.
Visitors center.
Barringer crater, isn't it? Yeah, you got it written there. Yeah. So yeah.
Yeah.
It's named after the person who actually bought the land with the intention of mining the iron from the meteorite which would be in the center of the impact. But when they started mining, they couldn't find anything because most of it had vaporized on impact.
It completely disappeared, and virtually they have found some very, very small fragments, but it's minuscule. It absolutely obliterated itself.
And if anybody remembers a very, very good science fiction film from the 1950s called "It Came from Outer Space," this is where a lot of it was filmed.
And also the Apollo astronauts trained there as well.
Yes.
Just look at the geology.
That's right. And of course, it wasn't it Eugene Shoemaker who proved conclusively that it was meteoric in origin and not a.
I think you're correct there. Yeah, I do believe you're correct.
Yeah.
I don't think there was any dispute about it really, but there we are. Anyway, it's quite a classic example, as you know. Okay. Someone said, put in the comments, they thought they bought it before the impact. I don't believe that's so, but I can't prove it. But anyway.
Yeah, you can see where the buildings are in the center. They did try to mine it. They put shafts down, but they found nothing.
Something in the middle. Yeah, definitely. Yeah. Anyway, there we are, folks. That's the real deal. Right. Now, Object B is the Ricket structure in Mauritania. That's West Africa, for those who don't know. It frequently gets photographed from space by shuttles when they were flying, and of course the space station. But it's not an impact crater, despite the fact that you'll find oodles on the internet saying it is. It isn't. It's what's known as a dome pericline. Basically, you can imagine a series of sedimentary rocks beds that are piled one on top of the other and bent into a sort of inverted saucer shape. And that's what you've got here. You can imagine creating a similar sort of shape if you took an onion and sliced the top off it and looked at the layers, looking down at the top. And that's what you've got here. There is some igneous stuff there as well. You can see that pink colored stuff in the diagram on the right there is igneous rock working its way to the surface. And it's quite likely that the intrusion of that large mass of molten magma underneath pushed the rocks up above it, creating the dome-like structure that you see here. So that's basically that. By the way, it's an interesting site for another reason, and that is a lot of Acheulean Paleolithic tools in the area. These are very, very early stone tools created by man's predecessors. But the dome pericline itself is much older than that. It's nearly 100 million years old.
Wow, that's old.
Okay, moving on. Right. Object C, well, if you thought it was, it is. These are the Clearwater Lakes in Quebec. They're actually in northern Quebec, adjacent to the Hudson Basin. And in fact, these are what are called astroblemes. They're basically craters that have been severely worn down. So the rims of the craters have gone, and you're just looking at the bottoms of them. Not surprising, since this location, being as far north as it is, would have been covered by the Wisconsin glaciers, great ice sheet during the last glacial maximum about 18,000 years ago. So a lot of it's been ground away, but you can still see them there. And what we have here, we believe, is an impact due to a binary object. An asteroid and its moon, if you like, crashed into the atmosphere and hit the surface side by side.
Wow.
Of course, we didn't know many years ago that so many of the small rocky objects in the solar system, for that matter, icy ones out in the Kuiper Belt, had binary companions, but we keep finding them all the time now. Yeah. Every time we do a fly past, yet another one turns out to have a smaller object orbiting around it, and most recently we saw a triplet. So there you go. It's a genuine impact crater. It dates back to about 290 million years ago, which is the end of the Carboniferous period. Wow. So there we go. Okay.
And in fact, Keith, if you look at an object like Arakoth, you've actually got a situation where the two components of the binary system came together very gently and united.
Yeah, they kind of just merged. Yeah, as you say, very gently. One more thing to add, by the way. It's a general rule of thumb, subject to a few extra conditions, that the older a planetary surface is, the more cratered it is likely to be. Obviously, there were a lot of bombardment in the early history of the solar system, and this gradually decreased with time. So the oldest rocks are going to reveal the most impact craters, and the underlying rock here is Precambrian metamorphic and igneous rocks. These are dating back billions of years.
Wow.
So in fact, they are much older indeed even than the crater that's impacted into them.
Great. Thank you.
Right. Well, if you said this was a crater, again, you'd be right. It's Wolf Creek crater in Western Australia. It's a tiddler compared to the ones we've been looking at so far. It's only about 870, I think, meters across. What's noticeable about it is it looks very flat. But the for that is that the inside is filled up with sediment after the creation of the thing. This is a relatively recent event. It happened about 120,000 years ago. There you go. When I say Western Australia, it's right at the north end of Western Australia, if you want to find it on Google Earth. Now, this thing that looks for all the world like a crater isn't a crater, or at least not an impact crater anyway. This is one of a whole series of large volcanic features that stretch down the western side of the Scottish Highlands, and which are associated with the opening up of the Atlantic Ocean, carrying America and Europe away from each other. And in fact, is also the intense volcanic activity that took place at the time is also responsible for highly elevated carbon dioxide levels in the atmosphere, leading to the Paleocene-Eocene thermal maximum, or PETM for short, which was a very, very hot period in Earth's geological history. The temperatures went up by something like about 10 Celsius over the average that you would expect at the time. So these igneous features, these volcanoes and so on, were creating a lot of carbon dioxide. This particular feature was one time assumed to be the internal plumbing of a volcano, but is now thought to be a thing called a lopelith. It's still an igneous feature. It's a large amount of magma injected underground into a sort of inverted saucer shape, which is what the diagram on the right shows you. But the diagram on the right is an oversimplification because the filling of this lopelith occurred in several phases. So you've got concentric layers of slightly different igneous material stacked one inside the other, giving again that sort of onion effect if you slice the top off an onion, which is what you can see in this aerial photograph.
I mean, looking at that aerial photograph, if I'd seen that for the first time, I would have thought that's definitely an impact crater, you know.
Yeah, absolutely. A lot of people do. This is, by the way, it's the Ardnamurchan Peninsula. You're looking more or less southeast in this particular picture. And it's the most westerly point on the UK mainland. You can't go any further west without falling into the sea or going onto an island. And it's just to the southeast of the Isle of Skye, which most people will have heard of. It's pretty remote. To get to it is quite difficult. I actually drove up to that place and stayed there overnight because you just couldn't really get around it in a day and get back to wherever you had come from. I had the indignity, by the way, while I was there, to be bitten by some unknown insect that caused me to come out in a massive urticarious rash. So I had to go to the hospital in Oban the following day and be injected with nicotine. But yeah, we are. That's Ardnamurchan. And it's, by the way, it's it's a classic training ground for undergraduate geologists. If you go there, I guarantee in the summer months you'll see somebody with a clipboard and a geological hammer wandering around. So there we have.
Fantastic.
Yeah, I think one of the UK spaceports is being built on that peninsula.
Well, Saxable.
Now that's interesting. If it is, then I'm not sure that's because there's a lot of things in the way if the rocket comes down. But yeah, okay, yeah.
Yes, Saxable, isn't it?
No, Saxavor's in Orkney, isn't it?
In Orkney, yeah.
Oh, yeah. Sorry, wrong one.
Yeah. It's I know the one you mean, Daz. I know the one you mean.
Yeah.
Dunstan Head. Dunstan Head is what you're thinking of. It's a finger of land pointing out at the top of Scotland.
Yeah.
Deal for launching northwards for a polar orbit, which is the most northerly point on the UK mainland, by the way.
Yeah, no, this one's on the western coast. It's I'm trying to think of the company who's
yes, I know the one you mean now. Yeah.
The big boys. It's not Sky Aura. It's the other one. Yeah, there is a. They are looking at building one there.
Orbex.
Yeah.
Give me a second, and I'll tell you exactly what it's called.
That again, sorry? The name?
Orbex.
Yeah. All right. Well, this, as I say, I photographed this out of a plane and thought, that looks like an impact crater. Went and looked it up when I got home. It's not. Basically, it's a large, massive igneous rock. And in fact, there are about a couple of dozen of them scattered over the Quebec area. This one is very nearly on the border with Maine, by the way, to give you an idea of your location. It's a large igneous intrusion. That is a body of magma that's come up through the crust. Didn't reach the surface, but subsequent erosion has driven off the rocks from above it, exposing it at the surface for all to see. And it's what's known as a stock. It's essentially a cylindrical sort of intrusion, and you're looking at the top of it. It's typically it's around about 100 million years old.
Right, that's the one you're looking for, Daz, is Space Hub Sutherland.
Yeah, Sutherland Spaceport. Yeah. That's it.
Sutherland. Right. Okay. That still baffles me a little bit because I still think we're back to where I thought of. But anyway, right. Okay. Object G is also not an impact crater. It's in fact what's known as a salt diapir or dome. In fact, this is in the Zagros Mountains on the southern coast of Iran, and it's actually a World Heritage Site.
Wow.
The best preserved diapirs in the world and largely unaffected by human habitation. What you've got is a blob of salty material moving up through the crust in the same way as the blobs move up in a lava lamp. But it happens much more slowly, of course. They are of interest because petroleum geologists will tell you that around these salt diapirs, you get traps, hydrocarbon traps, so they can extract oil and gas from these locations. So salt diapirs are a known hunting ground for petroleum. And indeed, the Anglo-Iranian Oil Corporation, which was the predecessor of BP, were the people out there drilling for oil in that area in the 40s and 50s. And of course, subsequently, in order to hang on to these assets, they made sure we had a compliant ruler of Iran, the Shah, who was, of course, subsequently deposed, as we all know. Anyway, these are around about 50 million years old. Okay, and if you actually look on Google Earth, you'll see loads of them. This is just one, as an example. Of course, the diapir has risen up from underneath and punched its way through the existing rock strata, hence the fact that they're dislocated by this feature. So this wasn't a thing coming down from above, but something coming up from underneath. And finally, Object H, yes, this is an impact crater. This is the Manicouagan Lake in Quebec. The reason why it's a lake, by the way, it's been dammed up as to make it into a reservoir, but it's a large impact crater. The central feature here, which you see quite clearly where the lake runs, is about 70 kilometers across, and the whole thing extends out to 100 kilometers. And this one is believed to be in the order of 215 million years old. And there was a mass extinction during the Triassic period, which corresponds with this impact. So it does seem to have had some effect at the time. So there we are, a collection of real ones and not so real ones.
Okay, that's fantastic.
Yeah.
Thank you. Thank
Can
you.
I say one last thing, by the way? I do believe geology to be one of the few sciences where experience is absolutely crucial. If you can think about it, in sciences like, for example, physics and so on, young geniuses come up with amazing discoveries quite young in life. Albert Einstein being a classic example. But with geology, really, as a geologist in the early 20th century said, A.K. Wells, he said the best geologist is the man or woman who's seen the most rocks.
Yeah, absolutely true. Yeah. Well, that's fantastic. Thank you so much, Keith. And I hope you'll bring us similar brain teasers like that in the future, because all very interesting, as they say. All right, so let me just sort myself out here. 1 second. That's better. I've got my mouse back. My mouse stopped working. Okay, just give me 1 second. Just talk amongst yourselves for a second. And there's
some
something I want
juggling.
to show you. So let me just share my screen, and here we go. Right, something I've just knocked up very quickly. Scotland spaceports.
Ah, right.
So let's just put that up there. Why is that not showing? Because Keith is hogging the limelight again. Yeah. So there we are. Right, Scotland spaceports. Let's zoom in this bit so we can see.
Yeah. Okay. Yeah.
So we've got Saxavord up in is it Shetland or Orkney? Orkney, isn't it?
Shetland.
Shetland.
Yeah.
I knew that.
Yeah.
Then we've got Spaceport 1 over to the west.
Yeah.
And forgive my Scottish geography. What island are we looking at there? Does anybody know?
Well, it's the Outer Hebrides, isn't it? So I'm not sure which one. No. I know Lewis is the top one.
Yes.
And south of Lewis.
The one to the west is on Benbecula, I think, which is one of the outer.
That rings a bell.
Yeah.
The surprise about that, it is already a rocket firing range for the army. My former teachers in my department was in the Royal Artillery and actually was stationed out there. He told me the wind speeds were so high they had to chain the caravans down to the ground.
Oh my god! Then we've got the one we were just talking about is right at the top. That's probably the one you were mentioning.
Right
at the top.
Sutherland there,
yeah. And then we've got coming down the Aberdeen spaceport, which, believe it or not, is in Aberdeen. Going across to the west, we've got the Prestwick spaceport.
Yeah.
And there we are. So these are all of the spaceports in Scotland that are currently being built or in the process of being designed and built. And we've got various legends there. We've got horizontal launches. We've got vertical launch. And as you can see, I don't know whether you can read this, viewers, but it tells you the maximum payload they'll be launching in kilograms for each one. So Prestwick and Aberdeen will have the capability of launching up to 800 kilograms worth of payload, and the one on the island there. So which island is that? Discover Space?
Benbecula, I think, or if it isn't, it's South Uis possibly, but it's one of those. Yeah.
Launches, aren't they?
Yeah.
The other, I can see there's one at Campbelltown on the Argyll on the peninsula there. Yeah, there's an area of flat ground there where the coal field is between the Holder Rocks, which is an ideal site for it because there's nothing to the west. Prestwick is already, an airport, was an air base one time.
That's right.
Interestingly enough, when I was a child, we used to have to drive across that. They had to close the road when the planes took off, and the road went across the runway, believe it or not.
All right.
Yeah, absolutely.
It's the only place that Elvis landed, wasn't it?
Yeah, Ian says it's Harris.
Harris
is,
no, Harris is further north than that.
Yeah, Harris is on the same island. Harris and Lewis are on the same island.
Yeah.
Yeah.
Okay. Thank you, Ian. Yeah. Right. So there we are. So I just thought I'd put that up very quickly to show you.
Yeah.
What plan? It's exciting that so many spaceports are now in the process of being designed and built in the UK. Saxaboard will probably be the first to launch if all goes well, and we've got a spaceport Cornwall, of course, which unfortunately.
Yeah, that's it's a shame what happened with but
that is a shame.
They are still working on possibilities for the future.
Yeah.
So yeah.
But of course, the UK is a prime site for launching into polar orbits. So it's attracting a lot of interest.
Yeah, I mean, not only have we got this spaceports, we've also got the space hubs that are being built all over the country, which are bringing all technologies together and everything. So there's a lot going on.
UK space is really, coming on really strongly. And there we are. All right, then. Well, I think time is against us.
Can I just quickly do this, Andy? It won't be a second.
Sorry. Yes, you needed to do your...
Unfortunately, for some unknown reason, this won't let me do a presentation type thing.
Oh, okay.
So let me just do this now. Right. I hope you can see this.
Yeah, we can see that.
This is the last 3 days of the sun. Oh, stop now. This is the last 3 days of the sun. Now, if you watch the eastern rim, look at all that activity come over. And there's also a bit of activity on the west with holes disappearing on the fire. But all this stuff is coming round. Now, these two that are right on the rim now, they're old friends. The top one was originally 3550, then it became 3614. Below it on the limb there, one firing off now, that is 3615, and that has actually grown bigger while it's been on the far side. The top one, 3550 as I know it, that's the third time it's actually survived going around the sun. But this is what's been happening in the last 3 days. There's lots of you can see the bridges of plasma that are there. But as you can see, this is all coming into space. It's completely different from what we had last week, which was totally blank. And as you can see, 30, I'll tell you, it's been designated a new number now. But what was 3615 has been firing off all the way along. But there's lots of flare action going on. There's lots of CME action going on. There's lots of filaments all waiting to lift off. And this is what's happened in the last 3 days. I'll just let it run out. In fact, I'll move on a bit so we can get to the end. Now, what we're looking for is that we've all this action, and I wasn't able to because I only did this just recently. Is that we've had two events again, and this will be exactly the same as it was Monday and Sunday. And what we've got, you can see here at the top. Remember, is looking down from the north. The top circle is the density of radiation, etc. And the bottom one is wind speeds, the wind speeds. Now, as you can see, there's just been a CME erupted off of the sun. You can just see it leaving the sun now. And then what we're going to do is, as I advance this, you will see that a second one soon follows behind. There he is. Yeah. Now, this second one is for actually traveling faster than the one in front. So it's catching it up rapidly. As you can see, it's heading towards the green dot, which is Earth. and you can see that they're not actually spot on sniper shots, but it is literally coming our way. And then what happens is then it comes up. You can see the second storm is catching up with the first storm, and by the time it actually hits us, it's actually caught up, and then it will hit us there. Now it's due to hit us on the 18th, around about the 10 o'clock time UTC, that is. Now remember, as I said, these two storms, they will not merge, but they will buffer up to each other. So the first storm will hit, and it would perturb our magnetosphere, which is protecting us, and it will set it up for the second one, which you can see is traveling a lot faster and is probably a lot more powerful. So keep an eye out on the 18th. It's going to be dark for us by that time, hopefully, and we could get some nice aurora. Okay, thank you very much.
Okay, thank you very, very much. Keep your eyes peeled, people. We won't get them this far south, of course, in Spain. But there you are. Ian's had a second try, not the Isle of Harris, but the Isle of Uist, he says.
Thank you. I did so.
Let's get rid of them.
Thank you, Ian. So there we are. All right, then. So let's wrap things up for this evening. If you've stayed with us all the way this evening, thank you. We do appreciate you watching us. Spread the word about Space Oddities. Don't forget you can buy the new Space Oddities T-shirts, the design of which you chose last week. Link in the description of the video. Link in the chat now. We hope you enjoy your T-shirt, and we'll all be sporting them before too long. I'm sure now they're available. Don't forget the hoodie is available. I'll be putting up a QR code for you to scan for that next week if you'd like one. So there we are. So from us all at Space Oddities, thank you so much for being here, as always. So just say a very brief good night to Michael.
Good night, good night, good night.
Good night, good night, Roger.
Good night.
Good night. Thank you both. Lou, thank you for your wonderful Eclipse, and get your wife on the program. We want to chat with her. So please do, and thank you for everything, Lou. Thank you to Daz. Thank you to Keith for your.
Thank you, everyone. Lovely seeing you all.
And we will be back, of course, inevitably. As sure as eggs is eggs, we will be back next week with more thrilling stuff from the universe, about which we absolutely adore telling you. So from us all at Space Oddities, have a fantastic week. Take care of each other. Be good. And if you can't be good, be average. And we'll see you next week. And thank you all so much. Bye-bye.